Hello students and welcome to this video. In this video we will solve question number 431 to 440 of permutation and combination. The link to download the PDF will be in description, as well as at the end I will show you how you can download the PDF copy of the books and keep them updated. And I will also show you my question answer application, web application, which I have developed for you guys. So without further ado, let's get started. Question 431 says that find the number of this p should be small. Find the number of positive integral solutions of the equation a, b, c, d, e is equal to 1050. So the factors are 2, 3, 7, 5, 5. Now for 2, 3, 5, maybe this should be 7, can belong to a, b, c, d, e. Thus we have 5 ways to put these. Both the 5's can belong to one variable in 5 ways, and the two of 5 variable in 5c2, that is 10 ways. The total number of ways of distributing the factors is 5 times 5 times 5 times 5 plus 10, that is 1875. Question 432 says that let y be an element of the set A is equal to 1, 2, 3, 5, 6, 10, 15, 30, and x1, x2, x3 be positive integers such that x1, x2, x3 is equal to y. Then find the number of positive integral solutions of x1, x2, x3 is equal to y. For y is equal to 1, there is only one solution. For 2, 3, 5, there is only one factor which can be put in 3 ways to 1 of x1, x2, x3. For y is equal to 6, 10, 15, there are two factors which can be put in 3 times 3 ways to 3 variables. For y is equal to 30, there are 3 factors which can be put in 3 to the power 3 ways to the 3 variables. So you see how many values we have. Total is 64. So 3 to the power 3 is 27, and this 9 times 3, 27, 27, we have 54, and for then 9, 63, and 164. Question 433 says that let xi is an element of z such that mod of x1, x2 through x10 is equal to 1,080,000. Find the number of solutions. So we take the factors as xi, which can be positive or negative, which gives us a factor of 2 to the power 10 for number of solutions. Okay, each number can be positive or negative. So 1,080,000 is 2 to the power 6 multiplied by 3 to the power 3 and times 5 raised to the power 4. Let the power of 2 among xi's be ai, then sigma I is equal to 0 to 10 ai. So you see this sum is 6, which gives us 15c9 is equal to 15c6. Similarly, powers of 3 here is 3, sigma bi is 3. So we have 12c, 3 solutions. And similarly, for powers of 5, we have 13c, 4 solutions. The total number of solution is product of these numbers. Question 434 says that let xi in z such that mod of x1 plus mod of x2 up to mod of x10 is equal to 100. Again, we have to find the number of solutions. So let r be the number of zeros in x1 through x10, then r would lie between 0 and 9. So there are 10c r ways to choose zeros. Number of non-zeros would become 10 minus r. When a positive integer a is given, there are two non-zero xi which satisfy mod of xi is equal to a. One would be a and another minus a. The number of solutions for a1 plus a2 up to a10 is equal to 100, where ai greater than 0 is given by 99 c9 minus r. Okay. So the total answer would be sigma r is equal to 0 to 9, 10 minus r cr, sorry, I'm reading it wrong. R is equal to sigma r is equal to 0 to 9, 2 to the power 10 minus r. This 10 minus r is 2 to the power, and then multiplied by 10 cr multiplied by 99 c9 minus r. Question 435 says that let there be n lines in a plane such that no two lines are parallel and no three are concurrent. Find the number of regions in which these lines divide the plane. So we let Rn be the regions made by n lines. Then R0 is equal to 1, R1 is equal to 2, that is 0 lines divide the plane in one region, 1 line divides the plane in two regions, 2 divide lines in 4 regions. Consider that there are n minus 1 lines with none of which are horizontal. Now we can draw horizontal lines. Now we draw a horizontal line. The n minus 1 lines will cut horizontal lines in n parts, which will divide the old regions in two parts, generating n new regions. So Rn is equal to Rn minus 1 plus n. So Rn minus R1 is sigma n, where n varies from 2 to n. And thus we have Rn is equal to 1 plus n into n plus 1 by 2. Now we move on to question 436. Determine the number of regions that are created by n mutually overlapping circles in a plane, assuming that no three circles pass through same points and every two circles intersect in two distinct points. So this is a similar problem. Let Rn denote the number of regions made by n circles. When there is one circle, the number of regions is 1. When there is 0 circle, it is 1. For one circle, it is 2. For two circles, it is 4. For three circles, it is 8. Let n minus 1 circles create Rn minus 1 regions. Nth circle will intersect with n minus 1 circles at 2 points, that is a total of 2 into n minus 1 points, dividing nth circle into multiplied by n minus 1 arcs. Each arc will fall in some old region and divide those regions into parts, thus generates 2 times n minus 1 new regions. So Rn is equal to Rn minus 1 plus 2 n minus 1, where n greater than or equal to 2. So Rn is equal to R1 plus sigma I is equal to 1 to 2 to n 2 into I minus 1, which gives us n square minus n plus 2. Question 437 says that determine number of ways to perfectly cover a 2 times n board with dominoes. Domino means a tile of size 2 times 1. So we have this 2 times n board. So the width is 2 and length is n. So let number of ways be wn. When w is equal to 0, we have one way to do it. When w1 is equal to 1, we have one way to do it. w2 is equal to 2, we have two ways to do it. Let n greater than or equal to 2. We divide the board into parts A and B, depending upon the domino placed at first place. A, those perfect covers in which there is a vertical domino at first place as shown in this figure. Okay. B, those perfect covers in which there are two horizontal dominoes placed in this first place as shown. Now perfect covers in A is equal to perfect covers in 2 into n minus 1 board. So mod of A is equal to wn minus 1. Similarly, mod of B is equal to wn minus 2. So wn is equal to wn minus 1 plus wn minus 2, which is a Fibonacci sequence. Now we will find the general solution using analysis. So we can skip this question actually to be truthful, okay? This solution is basically not meant for class 12 students. Anyway, we will at least read the solution. Let's see if we can understand. A power series of type sigma n x to the power n has a radius of convergence r greater than or equal to 0 such that the series V is convergent if mod x less than r and divergent if mod x greater than r. If two power series sigma n x to the power n and sigma b n x to the power n are such that they are equal for all values of x in some interval minus r to r, then n is equal to bn. Let n denote the nth Fibonacci number and consider the power series f of x is equal to sigma n is equal to 0 to infinity a n x n. If this series converges in certain interval minus r to r, then we have the following relationship for mod x less than capital R. F of x is equal to a0 a1x plus a2x square. X of x we calculate x square of x and so on. So when we do f of x minus x, f of x minus x square f of x, we get a0 plus a1 minus a0 x. So f of x is equal to 1 by 1 minus x square. Roots of the equation x square minus x minus 1 is equal to 0 are golden ratio. This is golden ratio alpha beta. So f of x is equal to 1 by alpha minus beta multiplied by alpha divided by 1 minus alpha x minus 1 beta divided by 1 minus beta x. We also make use of another power series x by 1 minus x is equal to 1 plus x square and so on for mod x less than 1. We see that n is equal to alpha to the power n minus 1 minus beta to alpha raised to the power n plus 1 minus beta raised to the power n plus 1 divided by alpha minus beta, and thus we have the general solution of Fibonacci series, which is the solution of this sequence. Question 438 says that Tower of Brahma or Tower of Hanoi is a puzzle consisting of 3 pegs mounted on a board and n discs of different sizes. Initially, all n discs are stacked on the first peg so that any disc is always above a larger disc. The problem is to transfer all discs to peg 2 with minimum number of moves, each move consisting of transferring one disc from any peg to another so that on the new peg the transferred disc will be on top on a larger disc. That is, keeping a disc on a smaller one is not allowed. Find the total number of moves required to do this. This is a classic programming problem. Okay, in programming there are 2 ways to do it. One is the iterative way, another is the recursive way. So let's see how we solve this. We let mn be the minimum number of moves that will transfer from one peg to another peg under given restrictions. By basic enumeration, when we have m1 is equal to 1, m2 is equal to 3. We first transfer n minus 1 smaller disk to peg 3 in mn minus 1 moves. Then move the largest disk to peg 2 and finally transfer n minus 1 disk to peg 3 to peg 2 using the same mn minus 1 moves. Thus, mn is equal to 2mn minus 1 plus 1. So, mn plus 1 is equal to 2 multiplied by mn minus 1 plus 1. That is equal to 2 to the power n minus 1 a1 plus 1, which implies that it is equal to 2 to the power n. So, mn is equal to 2 to the power n minus 1. Here a1 is this, okay, when m1 is equal to 1, so it is 1. That is the number of moves for one disk. So with this we have the answer. Now we look at question 439. 5 letters are written to 5 different persons and their addresses are written on 5 envelopes. In how many ways can the letters be placed in the envelope so that no letter is placed in the correct envelope? So it is a straight up case of derangements. D5 is equal to, we put in the formula, we get answer as 44. Question 440 says that find the number of positive integers from 1 to 1000 which are divisible by at least one of 2, 3 or 5. We let AK be the set of integers from 1 to 1000 which are divisible by 5. We have to find n of A2 union A3 union A5. So A2 is ceiling of 1000 by 2, that is 500, A3 is 333 and A5 is 200. Now we take the intersection of A2 and A3, we get 1000 by 6. So that is 166. We are taking ceiling as well all the time because we don't want fractions for the number of numbers. Similarly, and A3 intersection A5 would be 66 and A1 intersection A5 would be 100. A2 intersection A3 intersection A5 would be 33. So now we apply the set theory formula, we get the answer as this union as 734. So the number not divisible by the given numbers is 1000 minus 734, that is 266. With this we come to 440 questions, and there were some interesting problems in this, particularly last 440 and 438 and 437. These were quite interesting problems. Even 435 and 436 were quite interesting, so I hope that we have understood. If not, you can ask questions and I'll show you where you can ask questions. So come to my website astrologue.org to download the books. Okay, We have 3 books here: Algebra, Trigonometry, and Coordinate Geometry. When you download these books, the date will not be there. The date is here just in text. So when you download, add this date to your PDF, and once in 15 days, you can come to the website and check again whether a new release has been done. I have a lot of changes for this algebra book, which I will put in a few days. So lots of typing mistakes which I have found while recording the videos are corrected, and I'm working on converting this coordinate geometry book to talkbook. So this is the news. Okay, coordinate geometry book should be again available for download. It is available. I mean, the conversion may take 20 or 30 days. So that is one thing. Now about questions, you can come to my QA website, punjika.ashtavak.org, and make a login here, and you can ask questions. You can ask questions on these topics. These are the tags which you can make use of and ask questions on these. I will add more tags as well. For example, algebra can be split into several parts, which we have studied, logarithm and also on. So I'll add more tags, but for now we can use the tag algebra to ask questions. So make use of it. Okay. I think that's it. And now we can end the video here. So we will meet again tomorrow with 10 more problems on permutations and combination. I hope that you are enjoying the series and finding it useful for your studies. So I thank you for watching the video, and if you have got any questions, comments, or anything to say, make use of YouTube comment box. And for maths related questions, if you want to type maths, you can come to punjika.ashtavak.org. So we will meet again tomorrow, and I'll take my leave here. So you should keep practicing and have a nice day. Enjoy.